We got to start over. Sorry.
So we're now live. Sorry, folks.
So welcome to
messed
the
up
Cosmic Pie Podcast, Season 2, Episode number 9. I'm your host, Wayne Barkhouse, and here with me, as always, is
Robert Moore.
We are broadcasting live here on the campus of the University of North Dakota, here in Grand Forks, North Dakota. Today we have a very special guest that's joining us, Dr. Cameron Reed, Emeritus Professor of Alma College. Thank you very much, Cameron, for joining us.
Well, thanks for having me, and it's good to reconnect with you. And for your listeners, Alma College is a small liberal arts college in central Michigan.
So, Cameron, I noticed you're an author of 4 books that's been published already, and a 5th one is sort of on the way. In terms of that a layperson could understand, is that correct?
Well, yeah. So, are you seeing the slide here?
Yes.
We're seeing the slide. Yes.
Okay, so if I can be presumptuous and take the opportunity of plugging my books to improve my royalty checks, which are pretty infinitesimal. But it depends. There's kind of a spectrum depending on what a reader's looking for. So the one in the upper left, the physics of the Manhattan Project, it's about 250 pages. That's the hardcore physics. That's for a physics major who wants to get into the triple integrals of how you calculate a critical mass, or how to estimate the energy released by a nuclear weapon, some of the issues of isotope separation, and that's the sort of the guts of the physics. So that actually had come first, and is now in a 4th edition, as you can see. And then when I was working on that some years ago, it struck me that maybe something with a broader amount of the history might be in order. So the one on the upper right, also with the blue cover, is about 500 pages, and it includes some of the technical material at a somewhat reduced level, but also goes through the history of the project, how the history of radioactivity, how nuclear fission was discovered, and then the sort of bureaucratic origins of the project and how it came to be organized and who was involved, and how it basically how did it get set up and run, in addition to some of the technical issues they had to solve. Covers the Hiroshima and Nagasaki bombing missions, and Los Alamos, and a chapter at the end on some of the legacy of the Manhattan Project with some statistics on current nuclear weapons deployments and that sort of thing. So that's a broader view. And then the one in the middle is the
Whoops.
I don't know what happened there.
I don't know either. Well.
Oh, wait. I think I see what happened.
Okay.
I think I'm going to have to stop sharing for a moment.
Okay. Technical difficulties are part of the plan, folks. Or maybe not the plan, but part and parcel.
It's called Broadcasting Live.
Right? There we
There
go.
we go. I think I exited the slideshow by mistake. You seeing that again?
We're seeing it again.
Okay. So the one in the middle at the top is the qualitative version for a reader that's interested in the history and the underlying science, but without going into the nitty-gritty details of the physics. So it's kind of the think of it as the Reader's Digest version of the one on the right. But it's also about 500 pages, but gives surveys the project again from all of the background up through the the wartime years in Los Alamos and Hanford and Oak Ridge and Hiroshima and Nagasaki. So at a more qualitative level. Excuse me. The two on the bottom are thinner paperbacks. You see they have different publishers. They're each about 100 pages, and they think of them as kind of distilled versions of the larger ones. The one on the bottom left, pardon me, the bottom right, Brief Introduction to the Physics of Nuclear Weapons, is sort of the very condensed version of the history and science in the upper right. So it's really tries to boil it down to some of its essence of the underlying physics without going through detailed derivations and that sort of thing. And the one on the bottom left is a more qualitative version that again surveys the project more widely with its organization and history. And the artist in IOP ebooks here that made up the cover, I thought was very imaginative. He put the nuclear weapons powers of the world in red, and you can see Iran in orange and Israel in orange. And North Korea at the time was sort of a hatched business to try to indicate something about the status. So those are presently available, and at the present I'm working on another that's so I've been looking at this for years. It kind of became an obsession, and so over the years I had just gathered hundreds of documents and reports and dozens of books. And if you go online and just Google Manhattan Project, you'll get millions of hits. So it can be difficult for a reader to know if they just want to look up something quickly. It can be difficult for somebody to know where to go. And so I'm calling it a Manhattan Project encyclopedia, where it will basically going from A to Z, or A to Z, depending on how I want to pronounce it. But it will give kind of encyclopedia-like entries, condensed entries for people and places and committees and groups and technical concepts that are associated with the project. And they will all be cross-linked so that, say, the entry for Oppenheimer will cross-link to Los Alamos and what have you. And that's so easy to do now with powerful text editing programs. So there'll be cross-linked, and there'll be an extensive bibliography of, I'm now pushing about 300 references. So
Nice.
say a reader wants to see a facsimile of Einstein's letter to President Roosevelt, there'll be a description and then a link to where they can look it up in a book, or a hot link that could bring it up as a website. So it's intended as a kind of a quick survey with these sort of entries that readers can get to a specific topic very directly. I've promised my wife that that's going to be the last one, but I don't know.
So I just want to remind people that we do have a live chat. So if you have any comments or questions that you'd like to ask throughout the podcast, please feel free to do so. Now, Cameron, it's not hard to, when you talk about the Manhattan Project, to immediately get into politics. They're linked forever, essentially. So at this point, I'll just say a disclaimer that the opinion that Robert and I expressed today are not necessarily the opinion of the university or anyone else. You got to make that clear, because we will get into politics.
Yeah.
But I understand you, Cameron, you have seen the Oppenheimer movie, which is now the Oscar-winning movie, we can say,
Yes.
since Sunday. So what did you think in terms of how well it matched reality, or did you think that there were certain parts in it that were just way over the top, that never even came close to the way the things actually played out?
Yeah, I did see it when it first came out last summer, and you can actually get go on Amazon, get a copy of the script, which I found I had to do because in some cases with my hearing, the music overwhelmed some of the dialogue for me. But I mean, I enjoyed it. Obviously, it was a subject that is of great interest to me, and I think they had to. How can I put it? I wouldn't be too critical in places where some liberties were taken, I think, to dramatize the story a bit. For example, the scene where Oppenheimer goes and visits Einstein over their concern that detonating a nuclear weapon might set fire to the atmosphere. Uh, that was a concern, but he actually went and visited Arthur Compton, not Einstein. So I think they had to take a bit of Hollywood license to, to dramatize that. But I think by and large it was pretty, pretty truthful to the historical progression, and you're taking this enormous business and condensing it down to 3 hours. And I don't think there was a scene where Oppenheimer's visiting Enrico Fermi's reactor in Chicago. I don't think that ever happened in real life. But I'm certainly willing to overlook some
That's,
things like that because it, I think for a movie on a serious arcane topic, it's so dialogue heavy. It goes for 3 hours to be received like it has is really quite something.
yeah, you mentioned the visit to Enrico Fermi to his reactor, and that was one of the things that caught my attention because everything was, as they mentioned in the movie, so compartmentalized to try to break up word of what was going on getting out. You might find out about pieces of it, but the whole project was still a black box.
Yeah, they must have known about it, of course, but uh, it's remarkable to me that how, of course, not everything could be kept totally hermetically sealed, but I think it's remarkable what they did. And you wonder if it could be done nowadays with everybody and his dog has a smartphone.
Right.
um, and could that be? Of course, it's a totally different time. Um, I guess you can't really compare that to today.
Right.
But I thought the movie did a really and I think it really captured the personalities of the people involved, and then when they got to the scenes with Oppenheimer's security hearing, it really captured the political tenor of the times that he was subject to.
Now, I
So I
know,
think,
sorry, I was just going to say, I know that some people who went to see the movie who are not physicists and sort of a layperson to all of the subject material thought that the climax of the movie was the explosion of the bomb at the Trinity site. But to me, somebody who's has a physics background, I thought the actual climax of the movie was when Oppenheimer visited the president, and then when he left, that Truman said something to the effect of, "Don't ever let that crybaby back here again." Now he didn't.
yeah,
I understand he didn't actually say that at the time. He said that later on and called Oppenheimer an SOB type of thing, if that's true or not. But it's like that was like, Oppenheimer felt extremely guilty of the ramification of the development and then the eventual use of the atomic bombs on people. And then Truman's like, look, if anyone's to feel bad, it's me because I'm the one that had the ultimate decision in all of this.
Right.
yeah. I think Oppenheimer, in some ways, could be his own worst enemy. Um, his personality seemed to have been so complex that, and then he would come out with these sort of oracle-like statements sometimes that I think in some ways he just didn't do himself any favors with that sort of thing.
Right.
And of course, by that time, the genie was out of the bottle,
Right.
and
We do have a question, by the way. I hate to
okay.
interrupt you, but Mizuho Schwam asks, I heard that Compton made up a criterion to go ahead, and Gregory Bright
Mhm.
did a calculation to match against it. Is that true?
Okay, I didn't quite catch that, but this was about this setting the atmosphere on fire.
Uh, I,
Is
I'm
this?
guessing so. Yes, I'm seeing some nods.
Yeah, okay. Um, yeah, this apparently I've heard it attributed, or the solution attributed to a different person, but that so Oppenheimer went to visit Compton, who was at his summer cottage in Michigan, and probably just wanted a trip to Michigan. And Compton said, "Well, you got to carry through the calculations and just see what it comes to." But that it was Hans Bethe, the nuclear physicist, who uh, had debunked the calculation,
Hmm.
and that's described in Robert Serber's little book on the Los Alamos primer. Uh, and apparently, and in fact, I have a paper um, just published recently where I looked at the basic physics of that, and it was such a ultimately harebrained idea. The mean free path of a nitrogen molecule in the air, even if it's hit by directly struck by a high-speed fission product, is only going to be a few tens of centimeters till it loses all its energy by causing ionization. But the mean free path to cause another fusion is about 200 meters, longer than a
Uh,
football field.
Hmm.
And so it was just, and apparently Bethe had very quickly come to the conclusion that no, this is just not gonna, there's no possibility of this happening. But I guess the question just kept coming up again and again periodically, and they could never lay it to rest. Um, and of course, Teller was notorious for dreaming up these sometimes kind of wild ideas. So anyway, Serber claims that yes, it was a question, but for a few hours until Bethe had debunked it, and then they went on with their work.
It kind of reminds me of, remember when the Large Hadron Collider was ready to start, and there was this ideal out there that the collision of the protons would actually cause a formation of a black hole, would ultimately swallow the Earth. And
Yes.
they even went to court over it to try to prevent the machine from starting.
yep.
In fact, I remarked in the little paper I'd published that we're still here after over 2,000 nuclear tests, several hundred of which were conducted in the atmosphere. And so empirically, Bethe was correct. it,
Hmm.
it, it didn't set the atmosphere on fire. But it was, to be serious too, it was the sort of consequence they had to look at. Um, they were, nobody had ever thought about some of these questions before.
Right. I mean, you mentioned Edward Teller. So there's a big, I'm trying to go off my understanding of what I've learned in the past, whether it's right or not or partially correct, is that Edward Teller had this big desire to go beyond the atomic bomb, to develop the hydrogen bomb. And I think part of that was his upbringing in Hungary in the 1920s, where him and his parents, I guess, were subjected to the communists that were running the country at the time. And he was scared to death, essentially, of Russia eventually developing the hydrogen bomb before the United States, that they would use that as a way of dominating the world, if you like. And so that was the motivation behind Teller really pushing to get rid of Oppenheimer, who was being in the way, if you like, a stumbling block on this path of developing the hydrogen bomb. And Oppenheimer at the time, so this is before all of the security hearings and so on, that he said, no, that's as far as we're going to go, essentially. And then Edward Teller's like, no, that's a big mistake. And how can I make sure that the United States develops the hydrogen bomb is to get rid of Oppenheimer. And one way to do it ultimately was to lose his security clearance. Is that true in any way?
I think you've conflated a bit of the order of things there. In the summer of 1942, Oppenheimer held a meeting at Berkeley where he gathered together a lot of these people, including Teller and Bethe, many of their students, to look at the physics of what would be necessary to make a fission bomb. And at that time, Teller raised that possibility of a fusion bomb. But basically he was sort of 10 steps ahead, because you need a fission bomb to trigger a fusion bomb in any event. And they hadn't even begun to, they didn't have their first gram of plutonium by then. So they had to get a working fission bomb before any sort of practical consideration could go to the hydrogen bomb. But Teller they did do work on that during the war at Los Alamos. They were making some measurements of fusion cross sections, and so there was work being done on that. And then afterwards, when you get to the security hearing, I think the grounds that Oppenheimer objected to the hydrogen bomb were that they were so powerful, there was no credible military mission. In fact, even Enrico Fermi said this is a weapon of genocide, that there was no credible military mission that anybody could really conceive of to have this thing. But by the time, they had hundreds of fission bombs anyway, and so there was no, it wasn't as if the country was about to be overrun or something.
Right.
But I guess the political pressure on Truman was so intense after the Russians detonated their first bomb, their first fission bomb in 1949. The political pressure to proceed with the fusion bomb development, when they didn't, in fact, even know how to do it, was probably irresistible. And that's, of course, when all the trouble started for Oppenheimer. And so he got crucified, I guess you could say, for presenting an argument that was the rational argument, but overwhelmed by the political sentiment of the times.
Right.
Right.
And Teller, of course, remained in the 80s. Wayne, you'll remember the whole Star Wars defense system business. He had plans for doing large construction projects with nuclear weapons. And if a country needed a canal built or a mountain moved, and the joke was, if your mountain is in the wrong place, just send Ed a card. And it's some really stuff we would now regard as pretty outlandish. Oh, and the space-based laser weapons that would have been based on nuclear explosions on satellites.
Yeah, I mean, I can remember the Soviet Union, I think, debated that too, carving out certain lakes, right, in Russia with atomic bombs to make, different reservoirs for water and things of this nature, and all kinds of, like you said, crazy ideas to us today, but they were taken seriously too. It wasn't like it was just a joke that somebody mentioned.
No, not at all. And just think if that had transpired, how much more radioactivity there would have been in the atmosphere.
Yeah.
Just aside from the tests that they did.
Well, put all that together. So let's get a little political. The radioactive fallout, add to it all the pollution, and since the Second World War, let's say, how much of that ultimately contributes to the incidence of cancers across the world today?
Oh, there had to have been some. Somebody must have made some estimates. I think most of the fallout created by a nuclear weapon is pretty short-lived.
Right.
And there's a couple of isotopes that maybe have something like 30-year half-lives or a few decades, but the last United States test was in 1992. The last Russian test was about 1990, and they stopped above ground testing well before that. So a lot of that would have now decayed.
I used to make a point of mentioning to students when we covered radioactivity in the labs that people my age were actually slightly more radioactive than they were because of the strontium 90 that would have been in the atmospheres when we were, forming up.
When we were kids, and
Yeah.
it would strontium would I think it ended up in milk, did it not?
Yeah.
Right.
Because it's
It's in-
chemically similar to calcium,
Mm-hmm.
and that was the danger.
Right.
Um,
It wasn't like cows would eat the contaminated grass and then ultimately find its way into milk, cow's milk.
Right.
Yeah.
And then into
Yeah.
our bones.
Yeah.
And we've got another question. How would you rate Gar Alperovitz theory on Truman's diaries that the decision was made about the A-bombs in the war had a lot to do with USSR?
okay, I want to be careful how I phrase this.
What you say has nothing to do with us.
Yeah, of course I read his book. I think, okay, you guys are in the academic world. You know how academics can sometimes fix on an argument
Right.
and extrapolate it. Excuse me. I think there's a bit of that here, and for your listeners, I think that the gist of his argument is that Truman's decision, such as it was to use the bomb, was more about intimidating the USSR than about convincing the Japanese to surrender. I think that's the basic idea, and I think that's in a way. I don't think it was either or, and I'm kind of just giving a personal opinion here that in August of 1945, the options that were facing Truman and his advisors were pretty horrific. They could continue regular bombing and firebombing of Japan, and there was a firebombing of Tokyo that in one night had killed about 100,000 people. So Japan was being blockaded, and these bombing runs were going on, and the Marines are slogging through these islands on the Pacific. And I have a slide.
Okay.
Can I share my screen
Sure.
again here?
Yes.
Absolutely.
Let me see. Okay. I think. Oh, whoa! What? Jeez. Good, I wasn't in charge of the Trinity test. Okay, I want to show your viewers. On the left is a map of the southernmost island of Japan. I presume everybody's seeing this.
Yeah.
And so what was being planned at the time of the bombings was an invasion of Japan that would have begun on November 1st of 1945. So the invasion, it was called Operation Olympic, and there is to be an invasion of the southern island of Japan. So you can see the scale here is about 40 miles. And this would have dwarfed the D-Day invasion. The plan was to land about 750,000 troops over the first 90 days. And this would have dwarfed the invasion of France. And so the idea was that they would advance about a third of the way or so along that island. They would be setting up air bases for more bombing raids against the rest of Japan. And had the war gone on, the second phase of that invasion was scheduled for April of 1946 and would have been an invasion around Tokyo and would have involved over 1 million ground troops. And those numbers don't count all the offshore support forces and supply and all the logistics of getting fuel and food and ammunition and planes and everything transported to Japan. So the plans for the invasion were well advanced. And then, of course, the bombs became available. And so I think, to get back to the original question, kind of my own read on it, not as a military strategist or politician, was that there were two things that really prompted the Japanese to surrender: the bombs, and the fact that they could make more than one of them. And then the Russians declare war on Japan between the time of Hiroshima and Nagasaki. So I think that to try to isolate one of those is not fair in some sense.
Right.
And of course, you can't predict what might have happened differently. Some people ask, well, did they need to use two bombs? Could they have gotten away with one? Might the Japanese have thought, well, this is just a one-shot deal? So I don't think you can kind of isolate it in that way. And a question in that, extending that issue a little bit, the document on the right is a memo from General Groves, who was played by, was it Ben Affleck in the movie?
Matt Damon.
Matt Damon, I'm sorry. Groves and he was the commanding general of what was called the Manhattan Engineer District. It's a memo from Groves to the Chief of Staff of the Army, General Marshall, the day after Nagasaki. And he outlines a schedule that a next bomb, a third one, would have been ready in about another week or so, a week, 10 days after Nagasaki, which was the 9th of August. So the pipeline of bomb material from Oak Ridge and Los Alamos, or Hanford, pardon me, in Washington, was really ramping up. And there was a follow-up memo where he estimates that by the end of the year, they should have about a dozen bombs available. And General Marshall, whose writing is down at the bottom here, by that time, Truman had given orders to stop any more atomic bombings, and he says that it's not to be released over Japan without express authority from the president. And so Truman had ordered a stop to the bombings after Nagasaki, but Marshall was already beginning to think about the bombs as tactical support of the invasion.
Oh, wow.
To take out some of the beaches if the war had gone on to November. So it was the options they were facing, I guess, to get back to the original question, the options they were facing were just horrific. And I think, to some extent, Monday morning quarterbacking is easy. Who among us would want to be faced with such a thing?
Right.
Oops.
Now, wasn't it true that, or was it true that between the bombing at Hiroshima and Nagasaki, that the United States had looked for an offer of surrender from Japan? That
Mhm.
after, so and when they never received that, that's when they proceeded with the second bomb.
Well, they had a couple weeks before Nagasaki, at a meeting in Potsdam, Germany, between Churchill and Truman and Stalin. They had issued a surrender request to the Japanese with the conditions for surrender, and the Japanese had ignored it, and then the bombings proceeded. And I'm trying to remember the sequence of events. I think so. After, I may not get this quite right, the initial Japanese response after Hiroshima was something to the effect of, we will surrender, but we would be responsible for our own trials of war criminals, and the emperor would remain in his position. And the proposal back was that, no, you're not going to try your own war criminals, and the emperor will be subject to basically the control of the commanding general of the occupying army. And that was what ended up then, a couple days after Nagasaki, being the formally accepted terms.
So that's the difference between conditional and unconditional surrender, essentially.
Yeah. But it was known in the American political circles, certainly, that the emperor was such a high figure in Japan that he'd have to be retained in some, you know, incarnation or other to basically convince the people that this was the way it was.
Right.
Right.
Now, the other thing in the movie Oppenheimer, it's certainly near the beginning part. There's this big push of, the Germany's going to develop it first, so we got to get out there and get it going. Try to get there ahead of the Nazis, essentially. What's your feeling for how close was Germany actually to developing the atomic bomb?
Nowhere near. Um, in fact, in two of my books, the Popular History and the History of Science, there's a chapter on the German program, and it was way behind. There's some interesting historical confluences, actually. In early 1939, and I could professorially go on here, um, but in early 1939, a group of German physicists had written to, there were two groups, as it turned out, had independently contacted both the German army and the Ministry of Education that ran the universities, pointing out the possibility of fission as a weapon. And it soon came under army control overall, but it was never very well organized. And I think there's a lesson in there in that when I first got interested in this, I was just curious about the questions of the physics. How do you calculate a critical mass? How did they estimate the energy yield and what reactions were involved and that sort of thing? And then I began to realize that it went a lot deeper than that, that if you didn't have people who knew the government bureaucracy and the organizational structure and somebody like Groves who could really ride herd on such a thing, it would have remained in a lab. And so I think one of the issues in Germany was that there were personality conflicts between people like Werner Heisenberg and some of the others involved. Excuse me. If your listeners are familiar with some of the history, there was a man in America named Vannevar Bush who was the chairman of the National Defense Research Committee, which was a group authorized by President Roosevelt to coordinate scientific research that might be useful during the war. And of course, there was the Einstein letter to Roosevelt. So there was a direct appeal to the top. But so this started to get organized under people like this Vannevar Bush, who appreciated the potentiality, and he knew how to navigate the Washington bureaucracy, and would periodically brief the president personally on the progress. And there was no corresponding people in those sort of positions, I think, in Germany. There was no General Groves that really could coordinate this thing. And so there was, I guess, in answer to the question, there was a program in Germany. They built some experimental reactors. They never got close to a critical reactor. Their last effort in the spring of 1945 was getting there, but it was captured by the Allies and dismantled. And at exactly about the same time, in the summer of 1942, was when what became the Manhattan Project was transferred to Army control from this National Defense Research Committee, because the Army had the budget and they knew the contractors to make the factories. And that's when it really started to go into high gear, I guess you could say. And at almost exactly the same time in Germany, their program got deprioritized because they didn't think it would make any progress in time to affect the war. The Allies were interdicting and destroying supplies of German heavy water from Norway, which they were using as a moderator in their reactors because they knew the Germans were interested in that. And then the endless bombing raids later in the war just made their experiments impossible. They had a very minimal level uranium enrichment program that it didn't produce much. So that was certainly the initial driving fear. And you think of all these people like Hans Bethe, Edward Teller, Enrico Fermi, and many others that had fled Europe and ended up in America, were just, aghast at the thought of Hitler with a nuclear weapon. So that was certainly their original motivation, although it turned out not to be. There never was a race, I guess you could say.
Now, I did hear the story that, I don't know if it's true or if there's any truth to it at all, that people criticize Heisenberg for not leaving Germany. And they thought that he was involved in trying to develop the atomic weapon for Germany at that time. And that some people suggested that he was there because he was able to control the progress and slow things down to make sure that Hitler did not get the bomb before, someone else. Is that true at all?
Yeah, that is still. I've read a fair amount about that, and I honestly don't know what to think. He certainly, in the summer of 1939, just before the war started, he actually visited America. There was a physics conference in Ann Arbor, Michigan, at U of M, and his colleagues, people he'd known in Europe, were telling him, "Why don't you come to America?" But he felt, I guess, his feeling of responsibility to his next scientific generation in Germany. He went back, and he was certainly leading one of their reactor development teams. And the conflicting evidence, I guess you would say, is that in 1942, I think early 42, he was briefing some German army officers on how a reactor might work. But it was a very muddled description. And he seemed to be conflating reactors and bombs in a very confused way. For example, he had the neutrons in a reactor being slowed down in the uranium, but not the moderator. And it was very muddled up. And he apparently came to appreciate that later, that he got that muddled. So there's been suggestions that he did that deliberately to keep enough support flowing in to keep the reactor program going, and that he could save some young scientists from otherwise being sent to the front, but not really make, great progress. And you've probably heard of Farm Hall.
No.
Oh, okay. At the end of the war in Germany in May 1945, about 10 of the leading German scientists, mostly nuclear people, were rounded up, and including Heisenberg. And so these were the major people in their program, and they were held in England at a place called Farm Hall by British intelligence for 6 months, which was the longest one could be detained at His Majesty's pleasure. And but they were held out in this country estate in England, and their conversations were being recorded, and there was transcripts released in the 90s, and there's a book about it called Hitler's Uranium Club, where there's transcripts. I guess the recording mechanisms were primitive, and a lot of them ended up getting recycled. But after they heard about Hiroshima, Heisenberg gave this very garbled description of how to calculate a critical mass. And instead of getting an answer on the order about the size of a softball, his initial estimate was tons of uranium-235.
Wow.
Which would be utterly impractical. No bomber could have carried it, even if you could have gotten it. And because he made really fundamental errors in the physics of this. And then a few days later, he revisited his calculation, and and got the theory correct. And after he'd realized he had a muddled up model of neutron transport. And so there certainly seems to be consensus that his concept of the critical mass and how a reactor would work were very muddled up. And whether that was, but apparently also I read that he wasn't really interested in it. And maybe this is more the driving factor at the bottom. And I'm speculating here. That he wanted to get back to his research in things like quantum mechanics and fundamental particles. So he did this reactor business, probably didn't have a choice. If the German army says, you're going to be working on this. And he had, I could go on about this. He was in a politically perilous situation. Early on, sometime in the 1930s, he'd been denounced in an SS publication for advocating Einstein's theories of relativity. And that was denounced by the SS as Jewish physics. And he'd come in for some trouble with that and had to make a direct appeal up the chain of command to Himmler to put a stop to this. Excuse me. So he was probably in I wouldn't have wanted to be in his position.
Right.
He probably had to be very careful how he stepped in that sort of circumstance. And he probably couldn't not do this work. But then the question, I guess, is still open as to did he deliberately inhibit it? Was he legitimately really confused about these issues because his interests were elsewhere? So that's a long way of saying, I don't know.
Right.
Yeah.
Well, it's very interesting. The other you mentioned about Einstein writing or part of a letter, he put his signature on it that was sent to Roosevelt to get the president, the United States government, to think about developing the atomic bomb. Did Einstein regret that later? Because there's some mention in the movie, I think, where you implied that he regret that. But if we're thinking that the Nazis are on their way to do all they can, if that's the idea, to develop it, then one would think that wasn't a wrong decision to put your name on such a letter.
Yeah, I don't think I think he regretted what. I think to kind of take a little tangent here, your question touches on an issue that maybe gets conflated with this, that E equals mc squared is the secret to the atomic bomb. No, actually, not really in the least. A lot of the physics behind it was very classical physics and well-established nuclear physics, and they could very well make an atomic bomb with anybody ever writing down E equals mc squared. Now, I'm overstating a bit because that was used in interpreting what was going on in the reactions. But then the realization that a very powerful bomb could be made, is well beyond that. So I guess in one sense, he didn't have much directly to do with it. But he did apparently at the time feel that responsible people needed to be warned. And I think he, like many of the people that worked on this, felt, what are you guys seeing?
We
Just
seen you.
Okay, I'm sorry.
That's right.
I think many of the people at Los Alamos felt that they felt, how can I say, tainted, guilty, perturbed that 300 years of physics since Newton resulted in this thing. But on the other hand, a lot of these people had relatives fighting in the war, and the casualties were horrific, and it was a dirty job, but had to be done.
And we have another question. How about Mo Berg?
Oh, the spy. Okay, well, obviously you've got a listener that's really into the history of this, and so they may well know more about this than I know a little bit, and so I can just relate to your listeners. Mo Berg had been, from my understanding, a professional baseball player. And was he depicted in the movie? I don't remember.
I don't
I don't
remember.
remember.
Yeah,
Anyway, he'd been a baseball player. I forget for which team. Um, and he was recruited as a spy during the war by the Office of Strategic Services, which was a forerunner of the CIA. And he apparently was very knowledgeable, knew various languages, and they got him into Europe. And he was, I guess, one of his orders was to see what Heisenberg was up to. And so I think it was in Switzerland, Heisenberg was giving a lecture. And the story goes that Berg's orders were that if Heisenberg mentioned nuclear physics, he was to shoot him on the spot.
oh
Now,
my.
how was he then supposed to get out? Or, you got to wonder about how credible this is. But the story goes that Berg did attend Heisenberg's lecture, and it was some arcane lecture on particle physics. And so he didn't carry out the hit. But it sounds like it was quite a colorful character.
Wow.
Now there was along that lines, I think it was in late 1941 or 42, I might have the year muddled up, Heisenberg visited Niels Bohr in Copenhagen, and they had a fateful private conversation. Apparently no one else, there was no record of it. We only know what each related after the war, but apparently Bohr came away from that conversation with the distinct impression that the Germans were working on nuclear energy, and that Heisenberg allegedly slipped him a crude drawing of a nuclear reactor, which would have been a treasonous, if that's so, that would have been a treasonous act, one would think. And that Bohr then, after escaping from Denmark, ended up at Los Alamos and took that diagram with him. And this was, still part of the concern that what are the Germans doing?
Right.
Interesting.
Yeah.
Now, so when you think about it, but you mentioned the fact that at the time, of course, and we're judging things out of context because we're not in those shoes, right? Back in the 40s, right? So
Yeah.
when we think about what has happened, what has transpired up till today, one could argue that the development of nuclear weapons, so I'm going to broaden this out a little bit, has prevented World War III. In the sense that fighting World War III would be so devastating to our planet that life as we know it would no longer exist. And nobody wants to go down that road. So in some sense, it has saved lives, countless lives, if maybe World War III would have happened, let's say, in the early 60s. I think of the Cuban Missile Crisis, which was before, of course, I was born. But you imagine that, a major battle between the United States and the Soviet Union would result in hundreds of millions of people being killed. That all of that was prevented. So it saved all of those countless lives that we have no way of knowing for sure. But you could, it's not hard to by extension, to extend that out, thinking that has prevented, here it is almost 80 years later.
I think I call that the theory of nuclear inoculation. Seriously, that Hiroshima and Nagasaki let the world know just how horrific these things were. And so it, in some sense, inoculated us for a couple of generations against using these things. And but now we're speaking of events almost 80 years ago now. And I have some fear that is some of that wearing off? Is somebody somewhere in Ukraine or North Korea or India or Pakistan going to do something crazy? And I don't know, Bob, I remember from my childhood the Cuban Missile Crisis.
I'm so little before my time.
I was about just a young whippersnapper.
Yeah.
Um, but I can remember my father, in the basement of our house, I grew up in Toronto, he had a darkroom because he was a photographer. And I can remember I was about 7 or 8, my father putting supplies in the darkroom, putting some food and water down there. Not that it would have, but because there was such fear at the time that there was going to be a war. And, as a kid, of course, I had no real concept of what was going on, but that sticks in my mind. That memory sticks in my mind. My parents must have been scared out of their wits.
I mean, people laugh about it, but I do remember in the early 70s when I was in elementary school, we did indeed have the duck and cover drills where we got underneath our desks.
Yeah.
And I remember laughing about it with my fellow students back then. What is this going to do in a nuclear strike? So even as little elementary kids, we knew this was a joke. Meant to kind of make us feel better.
Conditioned us in some ways.
Mm-hmm.
And then you think of movies like Dr. Strangelove or Failsafe that took very opposite perspectives on that. And that whole... Did you ever see, there was a short movie that featured the duck and cover, and it was an animated thing with Bert the Turtle?
I've not seen that.
I think it was one of these Defense Department things, and so put out in the 50s, a civil defense kind of thing, and Bert knew how to hide inside his shell when the Russians started lobbing weapons. But when you think of some, and there was another one called The Atomic Cafe.
I've heard of that one.
And that is worth watching because it's a kind of a collage of these black and white clips from these sorts of things, and just the sort of the lunacy, the craziness to which this went at that time. And anyway, I think there's some credit. Suppose it might easily have happened. Suppose the bombs had been delayed a month, and the Japanese had decided to surrender. What might have happened subsequently?
Right.
Yeah.
Well, I don't find it far-fetched to think that there would have been a third world war, but who knows what would have come about due to it, Would those bombs have been used tactically?
Maybe in Korea.
Right.
Or something.
Right.
Well, didn't General MacArthur, didn't he propose using that?
I think
in the Korean War?
I think he did, yeah.
But by that time, the Russians had their own beginnings of their own stockpile.
And I know recently Putin has used that as propaganda to say, the only country in the world that has used nuclear weapons in the past is the United States. So he kind of, don't look at us as being irresponsible on the world stage, right?
Right.
So it's amazing, that's kind of stuff, totally destroying the history and what that all meant, of course, completely out of context, right?
Well, please don't get me going on him.
Yeah.
He'd probably say something inappropriate.
But I mean, it's important because you get some person who's head of the a power that has nuclear weapons, treating them like throwing licorice at you or something. Like it's ho hum. I threaten the West again with nuclear weapons.
Right.
That was on a Tuesday. What will I do on Wednesday?
Yeah.
Well, but it's scary too.
It is scary.
If people start thinking like that, boy, we're going to be in trouble.
Right.
And I think something maybe perhaps many people that watch the movie or your listeners, there's still thousands of nuclear weapons deployed in the world.
Right.
Most between America and Russia, but you have Britain, France, China, India, Pakistan, Israel, North Korea, all in that club. And so there's still thousands of these things out there.
Yeah, and you got other countries trying to join that club, like Iran, for example.
Yeah.
Yeah. And in the past, there were other countries like South Africa and Libya and even Sweden had a program for a while. So there was some, the proliferation is still out there.
Yeah,
Right.
I mean, even Ukraine, when it became its own country after the Soviet Union dissolved, they had nuclear weapons for a while till they agreed to give them up.
Yeah,
So what would
yeah.
how if history have changed if Ukraine decided to hang on to those weapons? I mean, maybe
Right.
Russia would have thought twice about launching their
You know,
Or maybe they
special
wouldn't.
operation.
Or maybe they wouldn't. And
Well, then you'd have a
maybe
nuclear
we'd have,
exchange.
yeah,
then who is playing the role of Japan and America?
Yeah.
right.
Um, yeah,
Yeah.
I mean, Robert and I talk, in the past on different podcasts about what would be like in the future, and you think of space exploration and stuff. And imagine you had a time machine. I always thought, if you can get your DeLorean up to 88 miles an hour and go 500 years into the future, in some ways I'd be amazed that we haven't killed each other because of some type of nuclear exchange due to some type of conflict, whether it's a rogue nation or leader, or it's an all-out, World War III type of situation.
Yeah.
500 years.
you ever heard of the Fermi paradox?
Yeah,
Yes.
yeah.
And that's been proposed as one
Yeah.
reason we haven't contacted them.
The great filter.
Right. So
The
for
great
those
filter.
for those of you who don't know about the Fermi paradox, the idea is where are all the aliens, if you like, extraterrestrial beings? They should be everywhere by now, populated, this area of our galaxy, if not the whole thing, if there's a lot of them, and we don't see them. So one way around it is that civilizations advance to the point where intelligent creatures annihilate themselves.
Right.
And they haven't reached that point where they, can propagate through the galaxy, if you like.
I mean, let's
Get
think about
beyond
it.
that.
The fact is there's more threats than just nuclear out there. We're getting to where genetic warfare and various biologicals are a threat.
Well, and do we, if every civilization goes through a kind of an Anthropocene era, do we overheat and pollute ourselves into
Extinction. Yeah.
demise?
Yeah. Well, just think of the buzzword AI now.
Right.
Whether it's artificial intelligence, which is we're not there yet, but people go crazy over that. But if you give another 300 or 400 years of advancement of technology, where are we then?
Would it
Right.
take even that long? Like would 50
Yeah.
years or 30 do it?
Yeah,
Right.
who knows, right? So I'm thinking of like Star Trek and the Borg.
We have been assimilated.
When you look at, I like to watch the old 1960s, the original Star Trek episodes, and I remarked to my wife that on almost every one of those episodes in the 25th century, there's still a fist fight.
Right.
Well, I mean, Stephen Hawking was famous, for saying a lot about we should be careful of broadcasting with our radio telescope signals out into space because you never know who's going to pick up those signals.
Right.
Yeah.
And they'll come here to, simulate us or whatever they plan to do, right? So
There was a quote that's attributed to Einstein, I think, that he said he didn't know what weapons World War III would be fought with, but World War IV would be with sticks and stones.
yeah.
Right.
Exactly. And I think that's probably true. I find it very hard to contemplate that if an all-out war is going on between, let's say, two countries that are nuclear powered, that when one country knows that they are losing bad, they will not resort to nuclear weapons. I have a hard job believing they will not do that. I think they will.
Yeah. We'll
When
burn it down
they're
if we
backed
can't
into
win.
a corner, I think they will go ahead and go nuclear.
Yep.
Yeah.
And
And once
that's-
it starts,
It spreads.
Yeah.
the cat's out of the bag.
Talk about a chain reaction, right?
Right.
Did you ever see that 80s movie?
Day after. No, not day after tomorrow.
It's the one where a teenager hacks into NORAD. And
War
accidentally-
Games.
War
War
games.
games.
Yeah.
Yeah.
Matthew Broderick.
Yeah. Yeah. And accidentally starts the countdown.
Right. And that's the one where, if you haven't seen it, so the computer at the end of it runs all the simulations of hitting each other and basically said the only way to win this game is not to play it at all type of situation. So there's no winner
Yeah.
in a nuclear war. That's
Right.
No.
It's a burn it all down because we're going to lose.
yeah.
Yeah. And that was Oppenheimer apparently likened it to two scorpions trapped in a bottle. And at the time of two nuclear powers, and they could only take out the other at the risk of killing themselves.
Yeah.
Right.
Anyways, well, thank you very much, Cameron, for doing this. I see our time is up, so we better cut it off here.
Yep.
Oh, this is great fun.
Yeah, thank you. Very informative, and I'm very appreciative of the fact that you did this for us. Thank you
Yes,
very
thank
much.
you.
Thanks, and I encourage your listeners to buy all of my books and get multiple copies and send them to your friends.
They make good Christmas gifts and birthday presents and so
They
on.
make great door stops. Yeah.
Well, if you're interested in physics and let's say you're in high school or you like to go back to university and learn about things like this, please consider coming to places like the University of North Dakota. We have programs both on campus and online, and get involved. I mean, when do you stop learning? As far as I'm concerned, when you die.
Right.
It's
That's right.
lifelong learning type of thing. Now, we always leave you with a quote. So fittingly, today's quote is by Hans Bethe, and he was mentioned a few times. So let me say his quote. So here we are. If we fight a war and win it with H-bombs, what history will remember is not the ideas we were fighting for, but the methods we use to accomplish them. These methods will be compared to the warfare of Genghis Khan, who ruthlessly killed every last inhabitant of Persia.
Mm-hmm.
And with that, thank you very much for watching.
Thank you, folks. Y'all have a good day.
Thanks.